Hi, my name is Brian Horn, and I'm going to be going through IPv6 with you. Before we started, just by show of hands, how many of you actually have implemented IPv6 and have it running today? Pretty good. How many of you are planning to do it? That's even better, the right audience. I'm a MikroTik trainer and consultant as well. What you see in the ad when we advertised it, it was going to be as from WISP-TRACON, which is the consulting side of the company. But looking at it and after running IPv6 training here this week, I made some changes, and I thought, well, I'd rather look at it from the other side and give you a background as to, from Winters Broadband, the one company that I own, as to what we went through and the decisions we made and how we made them and got it going. So we're going to take a look at it from that side. Give you a bit of my background. I've got an engineering background. Spent my first 20 years in TV broadcast engineering, and then moved into computer systems and networking. So I was around when Ethernet was 10-base-5 and 10-base-2. So I think most of you, that's when the limit was like 1,500 meters that we could make a network in those days. I founded Winters Broadband in 2002. It's a WISP in rural Central California. And at this stage, we've got just under 800 customers. So it's really nice little business there. And in 2014, we founded WISP-TRACON together with somebody some of you may know, Anders Ahrens, who's a trainer from Latvia. He runs a company there called Router LV. And we do training here and consulting here and in Europe. Looking at from the Winters Broadband perspective and where we were, we've had a ASN assignment from Aaron for a long time. Our number in the assignments is 19580. So it's in the early days before they had to go to double digits on the numbers. So we got a /22 IP address block. And the router network at the moment is 64 sites. We're running OSPF. All the customers have a public IP. But a few years ago, the problem was we're running out of IP addresses. And so we moved to /32 networking. So there was no subnetting. We didn't lose any addresses in that. And that really bought us quite a bit of time. We went to Aaron to get more addresses. And of course, they're not that easy to get nowadays. And our growing at the rate at the moment, and we're doing no marketing at all, it's just word of mouth, rate at about 150 customers a year at the moment. So our IP addresses will be depleted in the next 18 months. So when we look at network planning, there's a continual process addressing that. It's the network growth that you're having to do, the performance. And one of the things, if you're a WISP, I don't know in the other parts of the country, but certainly California, if you can't meet the federal standards of 25 down, 5 up, you can go to the state and get money to overbuild the incumbent that's there. So if you want to stay in the business, you need to be able to deliver those levels. So you got the redundant links, redundant powers. Part of what you have to do is upgrades. You have to look at your bandwidth requirements, the providers who you're getting it from, and keep ahead of the curve there. Netflix was a big problem years ago when it came out. A lot of WISPs got into trouble. They didn't have sufficient bandwidth with sudden overnight increase that was required. That was a lot of income for us. We just upped the service levels, and we got a lot more income from that. From the customer side, we offer residential from 3 to 25 megabits per second, and we offer business speeds up to 100 megabits per second. The businesses are symmetric. The residential asymmetric. And the other bit you have to do is manage your IP address pool and managing the addresses that are out there. So the IPv6 strategy we took a look at is what we'd like to do is offer IPv4 and IPv6 native mode right the way through. So when we looked at that, there were a number of questions came up as why should I deploy IPv6? When should we deploy it? Where do we get the addresses to do it? What do we know about IPv6? Looking back a year or so ago, And where do I get the information that I can make informed decisions? I know from the background, my background, part of it for a number of years was I was director of Lucent's Global System Solutions worldwide. And that I went around the world managing the major contracts for them. And there you really had to know what you were doing and what you could offer customers. So when it comes to applying it in my own networks, I know there's a lot of information I need to be able to make those decisions. What network upgrades will I need to make? What's it going to cost? And how long is it going to take? You know, once you've got that information, you can start coming out with a plan. If you don't have all that information, you're going to go out there and you're going to get caught along the way when you hit one of the hiccups. So if we look back at IPv4, it was first deployed in 1981. And the interesting bit about this is it's 32 bits. So it's only 2 to the power 32 there. That's all that's there. Interesting number when we come back to look at it a little bit later. And until 1993, class addressing was used, the ABCs. You know, nobody saw this explosion of devices out there, so you could just go get a class B address. It's quite easy to get. Today we look at some of the customers that we have where they've got these class Bs or /16s and they're not really using them effectively, but they got them at a point when there wasn't an issue in getting them. Today, if you need IP addresses, well, you're going to have to go to one of the auctions. And a /24 costs you about $4,000. I've heard people paying up to $5,000 this week. And that's just for 256 addresses. You want a /20, you're going to start paying $50,000 for that. So let's look at IPv6. That was first deployed in 1999 because they saw that it was going to run out of addresses. So now we've gone from 2 to the power 32 to 2 to the power 128. So we end up with this horrendous number of addresses that are out there. So we shouldn't run out in a hurry. Right? Gets a little crazy as you go down, as you'll see. So the way that's done is IANA controls the addresses, and they give it out to the regional registries, which is in America is ARIN, is our registry here. And then they will give out either private provider interfaces directly or normally to ISPs, where you'd be given a block and then you subdivide it out to your users that are out there. If we look at the IPv6 adoption rate, this is over the last 5 years. I cut the rest of the graph off. If you want to have a look at it any time, presentations will be available afterwards, but there's a link to Google. And I don't know, it's a little bit hard when you capture it to get the right numbers up top, but as you'll see up there, it's saying about 15%, it's actually a bit higher. It sort of stops where the number that appear there is where the cursor is when I go to the capture mode. But you'll see most of it is in native mode. Very little of it is in Teredo or a mode where it's translated. Interesting bit, if you look at the Google map as well, is the IPv6 adoption. So the green parts of the world where where the adoption rate is pretty high. So for us here in the US, you're in the right part of the world to do IPv6. Interesting bit about the map though, there are 2 red areas. There's one down in Africa, and I found that one rather interesting. There's one little place in Africa is red, and that means that they're not doing very much. Well, that place is where I'm from. It's called Zimbabwe. It's run by Robert Mugabe. He's one of the worst dictators. He rates together with the North Korean leader and how bad you can be. I was there a few years ago, and that's why I started my career out. I worked there for 2 years. We were a civil war going on. I decided, you know, the career was one thing, but your life expectancy was another thing too. So I moved on, and I went back about 3 years ago, and I managed to get some ministerial approval to actually visit the broadcasting organization. And so I went through there, and I was shown around and through the place. And we finally ended up in the news department, and the lady there explained to me that, you know, this is what we do, and she's very proud of her website. But she says we have no audio streaming. So I said, what about video? She says, no chance of that. I said, why not? I said, well, our internet connection is terrible. And this is the mouthpiece for the country, and the leader can't even get decent internet to them. So I'm not sure what they did wrong with Google to get red. And the other country that got the red mark here is Peru. I'm not quite sure Peru and Zimbabwe are in the same state there. So these are the ARIN fees and policies. If you already have an AS and an IPv4 allocation, then you qualify for IPv6 allocation at no extra cost. So as part of your charge that you're paying, you've got, say, a /22, then you qualify for something up to from a 36 to a 32 there, if I can read it, the angle it's at. So if you're already there, all you have to do, and it's a formality, there's no big investigation or justification. It's a fairly simple process to actually get your assignment. So that's where you'd get your block of addresses from. So for us, looking at the questions, why should I deploy IPv6? Well, I could go buy some addresses on the IP auctions, IPv4 auctions, but it wouldn't be a long-term strategy. For us, when we're going to deploy it, we'd like to complete the project in 12 months. And 12 months because we see 18 as being the goal and plan for the unforeseen. So where did we get the addresses? We applied to ARIN, and we got assigned a /36. No additional cost to us at all. So there was no problem there. So if you're a new ARIN member, you're multi-homed, you join, it's $500, and you can request an IPv6 block. And you'll get one, to say, in no case will you receive smaller than a /32 unless you specifically ask for /36. And then you see the fees that are available. So that's available to you there. If you're doing DHCP and you've just got a limited number of addresses from a provider at the moment, there is a policy 410 under which they will give you an IP4 block to facilitate your IPv6 deployment. But the block that you will get is going to be somewhere around, they give you the details in here. So this is for the NAT translators. So the minimum you'll get /28 to /24. So this is going to come out of a block they put aside just for facilitating IPv6 deployment. So what do you need to know about, or what do you know about IPv6? Well, when we looked back at it a year or more ago, it was a case of, wow, it's interesting, it's a whole complicated string of numbers. How the hell will I ever remember that? It's quite easy to remember that IP address when somebody says, 192.168.200.24. Yeah, I can type that in, but don't try dictating this. In the training this week is like, ping this, okay, it's Alpha Bravo Charlie 6 and this sort of thing. Double colon. And then the other thing at that stage is if you look at your PC, well, there's an IPv6 address in there, so obviously it's got support. And there is a limited number of people with IPv6 knowledge. And that's no insult to anybody there, but when we've gone ahead and we've got IPv6 allocations and we've connected to 2 carriers, neither carrier, and one of them was AT&T, could configure the end of the IPv6. It had to be escalated 2 tiers in the organization, and then that person said, oh, that's easy, I'll just do it for you now. But when you got called into the NOC, and it's a case of, well, my IPv6 is not working, you haven't done something on your side, when did you request that, and what are the details? And you give them, what's my, this is the address you've assigned to me. It takes a little while to get escalated through the organization to get it done. So don't be surprised. It's a big learning curve all over the place. When you're looking at information sources, there's the wiki. At MikroTik, there's the MUM. I haven't put the forum there because there are some things on the forum that where people have asked some odd questions, and some people are rather insistent this is the way you should do it. Not exactly what I would recommend. There's one person who thinks you should be doing IPv6 NAT, and since MikroTik hasn't put IPv6 NAT in, there's things are not really going to work. There's the IPv6E training course. There are consultants. There are a number of them around. You've seen 2 of them up here this morning that can help. And if you're looking at a book that's readable and not something that's a reference book, there is an IPv6 primer. That's the title of it. It was written by a Malaysian, and he did a pretty good job in putting the information into a pretty concise form there. And that's available on Amazon.com. The IPv6E training course is a 2-day course focused on IPv6. You do require to have the MTCNA before you take it. I would recommend, highly recommend, that you also do the MTCRE first, because it'll make it a lot easier for you. And then the course, the outline, it covers the introduction to IPv6, the protocol, packet security, transition mechanisms, and interoperability. And it's a normal 2-day course. So what upgrades do you need to make to my equipment to implement IPv6? Well, MikroTik simplifies that task for us if you've got MikroTik equipment out there. So if you're looking at the MikroTik routers, whether it's from the data center to the tower site, whether they CCR 1072s or 36s, or at the tower sites now, the CCR 1009 with the passive cooling, that's really a great product there. You could end up with micropops, where you've just got a small router there, and now there's a 960 PGS that's come out, that the gigabit powered, port powered. And then, the last data center, I need to correct. I did a copy and paste. It should say customer. One thing we have done with the MikroTik products, and it's something that we avoided for years, we stayed clear of providing routers to customers because of Belkin, D-Link, Linksys, Cisco, you want to go along, ASUS, down the list, and every single one's different. So customer, it's your problem. Until about 4 years ago, when it was becoming our problem, because what happens is unless you're managing the network right to the end, the customers will call in and say, well, it's slow. It's not performing. It's this or that. And then, so we went into managing them all the way. We have over 900 routers in the network that's managed now, right down to the customer level. When they call in, they have a problem. We can diagnose without doing a truck roll. And we can say, yes, you're paying for 9 megabits per second. You're using 8 at the moment. No, I'm not. Well, let me just look, and it's streaming out to Amazon or wherever it is, and the device that's doing it has got an IP address of this, and its name, by the way, is Susie's iPad. And you want to hear this yell, Susie, what are you streaming? And suddenly Susie stops streaming the video, and now run your speed test, and they've got it. But that managing is really important. And the reason we did it with MikroTik was the fact that all of those routers and the other products are on the same operating system. You don't have to know something different. So whether you're working on that one at home, that home router, or you're working at one in the data center or a tower site, same software, same interface, same command line. There's no different levels of training that you have to provide your staff. So that goes through for the wireless equipment as well. Whether it's backhaul or the CPE side, you've got the same operating system there. And IPv6 is there. It's in the standard package, the router OS that comes with the products. It's just disabled. So it's not, you just have to go enable, reboot the device, and you'll see that you now end up with a menu item called IPv6. Under routing, you'll find there's additions in there as well. So the features, just some of them that are there. Of course, you now got OSPF and the BGP, the OSPF v3, BGP on that side. You've got all the tunnels, IP, EOP, and GRE, all there for version 6. You've got all the PPP you're used to, that's there. And then you've got the whole toolbox of tools to support your diagnostics and your fault finding, all part there of the IPv6. What will it cost? Well, it depends on what equipment you have to replace. If it's MikroTik equipment already, it's not a replacement issue. It's just in enabling the other the IPv6. The big thing then is you have the performance in the device to start handling the extra load. And what we have in the network is a hand-me-down strategy, as where things might be at a tower site at one point, it might move down to a MikroPop. So the equipment that was bought a few years ago moves down, then finally drops out, depending on where we need the performance as the bandwidth that's going to take up. How long will it take? Well, it depends on how well you plan and how effective your upgrade process is. Once you've collected all that information, you're in a position to start planning it and doing it. So when you start looking at your subnet strategy, we got given /36, for example. Now, the smallest block that you assign to a customer is a /64. That's under the IPv6 rules. Think about that. That's /32 was the whole of the IP4 address space. Now the customer is getting a /64. It's an insane number of addresses that's given to a customer. So every little grain of sand in his backyard or something can get an IPv6 address. Well, we're seeing it come about, the cooktops, the refrigerators, everything's now, the light bulbs, everything's getting an IP address so you can control it in the home. And it's not necessarily because you want to control the refrigerator, but the manufacturers have got smart. If they can put the diagnostics into it and they can access it remotely, they know what to come out and bring out the spares when it comes to fix it. So now if you look at that and you start subdividing, and you, for example, decide that at tower sites, you're going to put /48, you can actually have 4,096 server sites, and each one of those can assign up to 65,000 /64s. So the scalability is unbelievable. It's there. If you went to /50, you can have 16,000 sites. Each will have 16,000 /64s on it. So the IPv6 just removes all the limits. This is why there's no need for NAT. Everything can be given an IP address. You don't have to NAT it anymore. The other thing that we do is, and it's a great thing with the MikroTik products, because they all run the same software and the same feature set, you can go and create test networks. So this is our network that we have as a test one. We got two 1036s, a collection of different 750s, 952s, etc., CCR. And then we have 4 PCs, and these are the Intel NUIs, so pretty compact. But with that, we can actually create a network, and you can actually be logged into the different sites, effectively, seeing what's going on. Remember, you can just upload the software to other routers afterwards. But what we also have, for example, this is a module from a tower site with a CCR 1009 passive cooled one in it. And that panel is held in place by 4 screws. So to do an upgrade to a site like that, we don't go out there and just try and do the upgrade of the site. Go there, pull the one panel out at some early hour in the morning or something, just put the other panel in, plug it in, power it up, and the whole site's upgraded. So whatever we wanted to change in the power control, whatever it is there, it's just done with rather simply. So going through those steps, and those are the steps we've been following. At this stage where we are, we've tested it the different ways through the network. We've had it, we have the links in from the internet. We have it distributed to our tower sites, a lot of them at the moment, and it's a case of getting those rolled out there and then rolling it out to the customer side. When I did the IPv6E training here this week, we actually had no IPv6 here in the hotel. So we did a VPN from here to California, and then a 6-to-4 tunnel over the VPN, and brought the IP addresses in that way. And one last bit is, congratulations to Tyler and Alan. I think they're the first 2 students in the US to get IPv6 certification. I think at the moment, until tonight or something, I'm most probably the only trainer. There's a whole lot more trainers going. They'll be writing exams later today to become IPv6 qualified. And then there is a training course coming up after the MUM that Redis Brazil is running. So that is that's scheduled here as well. So if there are any questions I can answer, welcome to take those. No microphone. Sure. Let me walk down so everybody can hear your question. There he is.
Sorry. So there's no default firewall for the IPv6 protocol in the customer device. So are you putting one on there?
On all customer devices, we put firewalls. Yeah. Any other question? Well, you're certainly in the right place to make cost-effective decisions and to deploy stuff with your MikroTik, products that you have. The thing to remember is you can experiment very simply with small routers on a bench, figure out what you really want to do the testing there. There's a question over here, Gaspar.
How do you typically route the address spaces to your customers? Do you use static routing or PD? What sort of scheme do you use to get the specific 64s per customer?
Well, we're working on the final bits at the moment, but the way we're doing the /32s, so the network's OSPF routed, and then the /32 address, because it's basically point-to-point addressing, is in the router at the tower site. And it'll be the tower site that will be the actual tower site will be giving the HTTP prefix delegation out to the routers there. Yeah. Any other? Okay. Any other questions?
Thank you. Any more questions?
One yes.
All of your customer routers, MikroTiks.
Oh, sorry. Go ahead.
Did you upgrade all of your customer routers to MikroTiks?
No, what we did was we made it rather. We had this customer base at a point. It was about 3 years ago. We started. We gave the option of a router. A year ago, the router came as part of the package. There was no option then. What happened was, going backwards, is if you called in and you needed a service call. Well, it's really easy. This is the charge for a service call. You want to avoid the charge, upgrade to a managed router. We'll come back out and we'll sell you the managed router, put it in, configure it for you. It becomes a managed service. So that moved people across pretty rapidly there. And we did do special offers on the routers. We were just shipping them out as in bubble wrap, envelopes, pre-configure them, ship them out, they plug them in. Nowadays what we're doing is that, of course, the CPE is powered off port 5 on the router, so there's no way of removing it. If you don't want the managed router, no option. It's always going to be there. We just turn the Wi-Fi off in it. You want to use Apple Wi-Fi? You use Apple Wi-Fi. But we can turn it back on and do a scan, see what's going on in your home, turn it back off, because the most common problems, things like an HP printer in direct, HP Direct, and it's causing interference or in the home or something like that. Yeah.
But so all of your customer routers are now MikroTik.
Yeah, they're all MikroTik now. There might be one or two holdouts well, they're all MikroTik, but they might not have wireless turned on in them, yeah. And some of the homes, by the way, we've worked with, once it gets out what you will do and the word gets out, we work with a lot of the building contractors now, and where they plan the networks in the homes up front. And some homes, I can tell you now, have 5 MikroTik routers in them. The WAPs are really great products now on the roof or on the wall outdoors, and because to get the proper coverage in the home, you're not just getting it from one router that's sitting, on a desk somewhere under some books.
Thank you. Do we have any more questions?
Well, thank you very much, everyone.
Okay, thank you.